Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Batum at Atlanta Functional Programming. Apologize for our evening edition again today. Um, but sometimes these things sort of happen. I hope all your evenings are going well so far. And if you're able to join us while we are streaming live, thank you for joining us. Those of you who are on the Jitsi meetup, thank you also for coming in and sparing your Saturday evening, even if for a little bit. Um, Also, a big shout out to our folks on the West Coast and folks internationally joining us on the Common Lisp Study Group stream. Before we begin, as usual, normal announcements. Those of you who are liking our videos and content, please feel free to subscribe to the Atlanta Functional Programming um, uh, YouTube channel, the Atlanta Functional Programming Group YouTube channel, and hit subscribe or hit the bell icon just so you can get more updates whenever we present materials, not only for Common Lisp, but other functional programming related topics that we tend to broadcast on this channel from time to time. Um, Additionally, as many of you may already know, Common Lisp Study Group is an open study group where we have discussions on Common Lisp. So if you have a Lisp topic that you would like to present or talk about, or a project that you're interested in, feel free to reach out to me. I am Bugram on Functional Programming Slack Tech 404, as well as the Lisp Discord server. Um, and so if you have any sort of like specific topics, reach out to me there, and I will be more than happy to have you get scheduled and be able to get us going with some with your topic accordingly. Today we're going to be continuing a bit of our discussion on the Chapter 5 exercise that we began last week, which is trying to essentially create a natural language interface that um, produces the input that the Eliza interpreter that Norvig created used without the use of parentheses and to be able to ignore things like commas and other punctuation. Last time we've already kind of came up with a simple example with the use of something that Norvig kind of brought up, which is the use of read line, which allows you to actually take in inputs from standard in and ignore punctuation and be able to create a version that doesn't require it. So, those of you who missed out on that, feel free to watch our previous episode on Eliza Part 2 to actually get more information on that. Today, we're going to kind of focus mainly on the named read table approach. Well, the read table approach, I should be very careful about that. Named read tables is the library that we're going to be using because we'd like to separate our read table modifications from time to time. And with named read tables, you have that ability to actually be able to take in your parsers, your different parsers that you create, add a label onto them, and in a particular scope be able to just switch to them so that within that scope of the function or subprogram or package you'd be able to actually then leverage that parser accordingly. So we're going to be leveraging that today, so we're going to be starting to talk about that. Additionally, we're going to also begin our discussion on chapter 6, which is just kind of a breather chapter between all the stuff that we talked about the last couple of weeks because we went and hit general problem solver pretty hard, and then we started talking about Eliza for a couple of weeks. And chapter 6 is more about, well, there are a couple of software engineering tool lessons that you could learn from looking at um, the implementation of those two uh, systems, and we'll be able to extract them and create some generalization tools. I will at this point will naturally mention libraries and or functions that are already available at your disposal, so you don't have to go and necessarily copy stuff from the book necessarily to implement some of these things, because they are actually so common now since this book has been published that they're probably in some library that you're already either using in your projects today or probably looked at in the past and didn't realize that this came from this kind of like history, this kind of heritage. So we're going to be talking about that today. As usual, most of these discussions are open-ended. So while we are, going and talking through these topics, if you guys have a particular topic that you want to discuss, by all means, reach out and, uh, the we'll go ahead and, answer those questions accordingly as I see them. All right. So to begin with, as many you may see here, I've actually went ahead and restarted my list, but I actually created a PAIP exercises repo for some of these stuff. This is going to have my opinionated kind of approach to actually implementing these kinds of things. I would love to see other folks share their solutions to some of these exercises, so we can have some discussion on, different ways of implementing things in Common Lisp. We can even highlight some even really kick-ass variations of the ones that are being shown here on the stream. So folks who come up with different solutions to some of these exercises that we're presenting here, by all means, post your repo URLs in the comments section, and I will highlight them for folks to actually go look at your work, as well as even do some interesting code review to see if I can learn anything from them myself. So last time, um, since I have this repository, I thought I'd just quickly show you the setup, just so you guys are aware of using. Um, yeah. So this is a pretty simple setup. I used CL Project to actually generate this. Our testing section's all constructed from there. As many of you know, CL Project I've actually reviewed on this stream multiple times. It's my go-to tool for project generation for Common Lisp, because it creates a very standard project structure with unit tests using almost everything that I tend to use anyway for Common Lisp development, from the use of Rove and its successor Prove for unit testing, to just the general structure for being able to quickly set up the ASDF operations commands, and such on this, so that way you could you know get up and running very, very quickly. My particular project, ignoring the fact that I forgot to add the author in there, uh, includes four main libraries. Obviously, I use Norvig's library. Has PIP has a what's it a has a dependency, mainly because of the fact that, especially since I'm adding extensions to his exercises, rather than modifying his project directly, just add it in here, put a new namespace and new things, and we'll be able to use his APIs directly. The other thing that I used, as we were talking about earlier, is the name readtables library, because that's what's going to be used for creating our Eliza syntax namespace reader. Also, I added split sequence for this, and we'll see that later. But mainly, split sequence um, as the name implies, a very high quality split library that would do string splitting that you would otherwise use something like, say, CLPPCRE to actually write out the regular expression to take a string and then be able to parse it. This will do that for you with some common sequence like APIs that is very familiar to most Common Lisp developers. So I'm thinking of things like split sequence if not, and so forth. Finally, um, I'm leveraging the Alexandria library, which I tend to use more frequently than other libraries. There are alternatives to Alexandria, or even sometimes they would consider them extensions, like Serapium. I think, mentioned Serapium at some point in the stream. So I encourage you guys to look out at our previous episodes for more information on that. Um, these are kind of the four main libraries I'm going to leverage for the time being, until we pick up additional libraries, and we may end up leveraging and creating our own as we are going through these discussions in these chapters. So are there questions on the dependencies? Okay, let's go back. So last time when we talked about the Eliza stuff, we looked at creating a reader macro like natural language interface on top of what was already provided to us from the simplistic implementation that Norvig created to us. We're not actually changing the rules at this point, but we are leveraging the fact that um, it is being able to use S expressions, pass in, has inputs into its flattened implementation and its ability to actually go in and produce responses in, again, S expressions that it could then spit out to the console. Now, the one thing, if you recall, that we were encountering is this doesn't actually allow you to deal with things like, say, punctuation and things. And we want to be able to at least be able to allow the user to provide such punctuation when they are interacting with this conversational dialogue tool. So um, to go to this, I started kind of constructing what we did last time. I did some updates here. We've have our read space stuff that we kind of talked about, and that's returning stuff. Our initial Eliza syntax that contains the ability to read these kinds of things. Now, naturally, right now I'm not leveraging it, but obviously at some point we will end up hooking this all together, hopefully throughout today's episode, before we get started on talking about our refactoring and software tools topic. So I kind of been playing around with the get next line stuff that we started with last time, and I kind of constructed this simple example, although it's not entirely complete because originally I had a different version of this, which I'm going to show you right now. Give me a second here. This one. Where was it? It was read string from in. Ah, there we go. This guy. Um, Hold on, not that one. One more, couple things. There we go. This is one. Let's go ahead and, oh, we need to first load in the project. My apologies. I forgot to load in the project. Let's do that quickly. Wait, let's just do this. Okay, PAIP exercises. Okay, there we go. Now we can actually do this, and we'll end up seeing that it's code. Actually, this is not entirely complete because of the fact that originally I had this as symbol. I was trying to play around with this to get exactly what I wanted, but then this is kind of worked with. So the first thing that I created was get next sign, which kind of looked like this. And basically, this is going to just take in whatever's in the input, has natural language, and then convert it into essentially a list of strings. So if you look at how get next line kind of works right now, what this does is, and as you can see, this is taking an optional argument because we can actually pass in any sort of stream into this. For right now, I attached it to standard in. I could specify kind of a sentence here, and if I return it, you can see that it converts it into a list of symbols from this. Originally, it was going to be something that looks like this here, um, where I did not even do map car symbol. And I just did something like that. But this naturally had the consequence of if you type in our sorry, autocomplete gives me a problem sometimes. Um, you end up getting something like this. So it parses it, creates a split sequence, it generates a list of strings to you, tells us how many characters have been bitten out. That's fine, but the problem is unfortunately, if we recall how Eliza actually looks at this, and we can see this by just going to our Eliza 1 implementation here. And you can see that the way it actually leverages, I think it's probably better for me to just show you this by saying PAIP requires Eliza to load it up. Okay, now I could do PAIP : Eliza, and we got the ability to actually run this. So recall, if I do, I have to write something like this, and then it will actually um, be able to respond to you. If you type in hello like this, it won't actually do anything. Wait a second, did I? Oh, right. It's because I'm using the wrong version. Let me see if I end up. Let me just make sure that it is. Nope, this is correct. This is the Eliza rules, but for some reason it might be using the wrong version that we're leveraging. Oh, because I loaded Eliza, not Eliza 1. 1 second. There we go. And let's do Eliza. What is it? 1 second. I may have to actually go and redefine this. 1 second. Let's do this. I may have to reload this to kind of show you what I'm talking about. Give me a second. This load, go here, load, now require Eliza 1. Okay, perfect. Now if I do PAIP Eliza, this should give me what I'm expecting. Huh. It's not of type sequence. Okay, so I have to say Eliza hello. Let's see this. Undefined Eliza. Oops. Sorry. It's because I didn't turn this on. Eliza hello. Huh. Eliza, I felt good. Let's see what happens if I did that. Oh, it's still not able to respond. That's interesting. Maybe it's not liking the fact that I am. Let's see if I can do Eliza by. Okay, it is using the wrong set of rules, it looks like. Let's do this. Oh, right, because it can't actually see those. I may have to go and switch namespaces here. One moment. Shift. There we go. Change package or set package to PAIP. Okay, let's try Eliza here. Ah, there we go. It's because I couldn't find the rules for some reason. Because those are it's an uninterned. It's the Eliza rules global variable, sorry, not global variable, special variable, um, is not exported outside of the PAIP package. So unless I'm in that package, it can't find the rules. So it couldn't. It kept on getting a nil, and as a result, that's actually um, need to get that set up. All right. So let me just see if I can. Oh, sorry. For some reason, Eliza by. Let's see if this works. Oh, right, because we don't have the by implementation here. Hold on. I thought by is actually part of the rules here because we kind of wrote through that. Okay, go here. Let me see what is. No, by is not on top of it, so I have to go in and actually do this. Okay. All right. There. All right. One. Okay. So we've seen from when we were looking at that before, it was using the S expression syntax to actually go in and parse this stuff. And so what we are gonna have to do is we're going to have to um, update it so that it can use natural language and ignore the punctuation. First things first, one thing that we did notice from this exercise is that our package that we're currently defining does not actually leverage PAIP here, and it doesn't actually leverage the exported symbols. So let's go ahead and say we're going to use PAIP like so, because we kind of want those symbols to be available to us when we actually um, getting down to it, you know. Um, Next, what we're gonna have to do is our goal is to eventually get to the point where we could do kind of what the Eliza top level is doing, which is being able to do flatten, use Eliza rules, and read. Okay, and then write out stuff. So our goal, if we look at our version of Eliza, if you will, would be, and we'll call this AFP Eliza, okay, which is just going to be kind of the same kind of idea. Is we're going to create a loop here, and then we're going to kind of print the same kind of like prompt, except it's going to be AFP Eliza, and then we're going to end up leveraging PAIP's colon write. Okay, and then we're going to then call their flatten method, although flatten, there are plenty of other flatten ones that are out there. And then we're going to call um, use Eliza rules on, and this is where things are going to change. It's going to leverage our kind of like get next line, so to speak. Okay. So like right now, if we do it as it's currently written, what this is going to end up doing is create um, something like what we have earlier, but this is currently not using readtable. And the reason why it is not using readtable just yet is because of the fact that you don't necessarily need readtable to test this out. The readtables mainly comes into play when you're trying to get set up and modify the Lisp reader to have this as a default set of readers when you're looking at stuff. So um, let's call AFP AFP Eliza, which will do this. And if we call hello, you see that right now, as it stands, this rule, this get next line, isn't actually set up to match what is expected by use Eliza rules. And that's because it's returning a list of strings instead of actually a list of symbols. So what we need to do is we need to go up a level and actually convert that list of strings into a list of symbols. So how do we do that? Well, I thought I can actually just simply do something like, first, hold on, I gotta get me out of here. I thought I could just simply do the following. Map car, yeah, symbol, and be done with it. But this also has the problem because if we see what happens here, get next line now actually provides us a list of symbols, but they are not in the format that's expected by Eliza. Eliza is looking for essentially quoted symbols here. So, and so if we end up calling this out, we'll end up having what we have before, which is a no response coming in. So we're going to have to kind of convert that and figure out what is required to actually get this working. Because if I do, let me see something here. If I do make symbol here, does it create it? Okay, it creates an unturned symbol with the bangs. Quote actually does what we expect it to. Or we could actually, let me see if I could do. Ooh, maybe read sequence might do it. No, because that's actually going to, that's reading in something like a vector. So like if read sequence, if you actually use read sequence like this and say vector, this will, oops, I have to actually provide, say standard input, there we go. And the vector is not of type sequence. 1 second, what does this do again? I thought read sequence actually reads in a sequence from, oh, got it. So if I do something like, say, this, you could actually modify the sequence if you end up adding stuff to this. Okay, got it. That's the wrong one that we need. We need to be able to actually do something else. Maybe format might be able to help us. Let's see. Let's look at the format documentation. Lisp. Ah, so maybe I can use that. I can use this instead. Let's see what happens if I do that. This is allows it to become a readable character. So this is a test. Let's see what happens. Ooh, okay. So this isn't actually doing everything that we want it to do because it's taking each of the individual characters and making it readable. Maybe that might work. Let's see. Let me try doing that and then do cpwr and let's do map car read and let's see what happens when I do that. Okay, and let's do this a test. Is not of type stream. Okay. Um, lambda x. Oh, I shouldn't say. I should say read from string, not read. Read from string. Let's see if that works. Okay. Simple example. This. And unrecognized character name. Okay. So right now those aren't actually readable. So this will not work. So let's see. What else can we do? Because essentially what we're trying to do is we're trying to leverage readline. Um, but so like for example, if we do read from string, all right, and I'm just gonna show this to you guys. Um, let's say that we use so we could use read from string if we had a string that was parsable to being a single character. So if I did here read from string this, you'll see that it will actually convert this correctly. Maybe that's what we could do. Let's see if this works. Map car. If I actually spell map car correctly, and then do this read from string. Ah, this looks a little promising. This is a test. Boom. Okay, so I think this might actually work. So let's do that instead. And let me just check one more thing. This. Oh, right, because I can't actually put punctuation. Let's just do this. Okay, and let's write out print get next line. Right, I'm gonna have to actually first do with output to string out. Let's write our input that we're going to write to out. This is a test. Okay. And then what we'll do is we will get next line from out. So this is one of the nice things about designing it this way, because now I can actually test it by doing this as is. String output stream is not a character input stream. Oh, okay. So what I'm going to have to first do is, instead of using with output to string, I need to use with input from string. From, and then let's just do in this is a test, and let's see what happens here. Nil is not of type character. Did I provide something incorrect here? Oh, let us do, that's right. I have to put a new line here, otherwise it will get mad. What? This should actually have written up what I expected it to. So the problem is basically the end of the string is being passed through until it hits the format, and it's not recognizing in the loop. It's not allow. There's an issue because it's trying to write out a nil character has part of the word, which is not what we want. So there is a bug here. So let me just fix that. Null item or character equal new line. Let's try that. This should work. Let's make sure we didn't break our read line from the actual REPL. Okay, so this looks good. Let's do this one here. Make sure that that's also working. Okay, so print. Okay, get this out of the way. Let's add the punctuation, and then we're going to start having to deal with the punctuation issue. This is a test. I'm just adding the punctuation. This is technically not a correct sentence unless I say something like hello, comma, this is a test. Okay. So if we run that, you can see that the comma gets removed because comma is a special character in Common Lisp, but period is not. Unless you're hitting the REPL here. Uh, as you can see, if I type in period, it actually stays away. So what we have to do is we're gonna have to like get rid of the punctuation ahead of time. And the way you do that is you could add, since we're reading this character by character, we can actually go and update this to what's it leverage um, to leverage like some reader special characters things that are available for us. So like in Common Lisp there is read punctuation, because we've done this before with the example that was provided to us from right. we can actually add an additional thing. We've done this actually last time. We needed to add like the a predicate punctuation p char, and then we just need to check to see if it contains any of these special punctuations. We can just eat it. So one way of doing that is we do I'm just going to add like one of them. There are other ways of doing this, like with CLPPCRE, or earlier what we did was is we just checked to see if actually this is probably better. Find, we could do find item char. Let's do this in no, this may not work. We could do this this way, but we'll see if it works. These are just a subset of stuff that we could look for. And if this returns, hold on one second. Thank you. Oh, shoot. That's not what I wanted to do. One second. I gotta bring back. Here we go. And let us do this. And disable showing. Okay, disable showing. 1 second. All right. Now, if you recall what find provides us, find is nothing more than providing us a non, if I remember correctly, it is, hold on, this is describe. This is the function notation, but I need this. Whoops. 3. That's right. I need to say that it's a function. Okay, done. Oh, so what does describe do then? Call foldable keyword equals. This should be all we need when we're doing punctuation because it returns nil. And then we just need to provide here punctuation. Okay. Yeah, it's not liking my my string there, so I have to get rid of that. Otherwise, Doom Emacs is getting a little finicky. Give me a second here. Let me just take this guy out. Okay. Do that. Okay. and let's say item. Okay. And here, let's just add a couple of, dashes and characters and, question mark. We don't need actually this, although that might be useful, but we don't currently need that. Okay, and let's run this. Now, if I go and run get next line, we'll see that this should eat up our punctuation. This is a test, period, and punctuation P is undefined. What are you talking about? I just, 1 second. Oh, I spelled it right in the first one, wrong in the declaration. Okay, do that again. Now, this is a test. And you can see that we've eaten it out. Now, this will actually work if we called AFP Eliza and then just simply say hello. This should actually convert the way we expect it to. But it still has, still needs the ability to actually get the Eliza rules, right? So what I need to do is, that's a little surprising. I was hoping that this would actually do what I expected. When I use package, let us do this. I'm gonna, because I defined the package, it might be the fact that I have to reboot my Lisp image in order for it to recognize that the package was defined now to be used. Let's see if this works. Because this sometimes happens when you're using packages and you extend the package with the new package that you want to use. And by use, I mean pass in those symbols as if they're part of the package in the first place. And actually, in that case, I really don't need to actually specify. If I'm doing use, I shouldn't need to specify these, but we'll see. Sometimes if they're internal symbols, the namespacing is required, um, but we will see. Okay, now let's go ahead and call QLQload PIP exercises, and boom. Okay, looks like this is good. Let's load this up and shift AFP Eliza. It'll create that. We say hello and is undefined. Okay, so it is not actually getting the export. It's only dealing with the exported symbols when you do that. I didn't think that it was necessary, but okay. How would we work around this? Let me see if I could do this. PAIP requires Eliza 1. There we go. Then this should make things all defined in the same region because we've now added it into our Lisp REPL. Okay. Now let's see if this works. Okay. Now we load it. Two undefined functions. Okay, requires it. Let's do this. Oh, because this is still required. This is the old one. Sorry, sorry, sorry. Um, Dynamic string input. Um, mm, that should have worked. Hold on one second. Let me see this. I will move this over. It has to be namespaced, and it looks like the only way to get this working is I'm going to have to copy this entire thing over to his code to actually get this working. I'm going to make a mental note to myself to actually go and see if I can figure out how to get these exported. Probably means I have to go into Dr. Norvik's code and actually go and make them into exported symbols into a package, which is fine. I'm, since we're going to be doing a lot more of these as we go along, it will be more important. It will be better to have this kind of properly set up. But this is kind of like the first time that I've actually kind of played around with this. Um, okay, so there was a comment here in the things. Let us. Hold on one second. Um, all right. So let's see if I could do this way. Eliza 1. Um, Actually, let's do Eliza. No, we'll use Eliza 1 for now, and then we'll switch it over. Um, okay. So if I do, ooh, let's do this. I bet you the problem is this guy right here not being explicitly called out like that. Let's see if this, okay, let us do one more thing. Oh, right, hold on. Bring back that. Now, let's do that and say hello. See what happens. Ooh, okay. 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 Let's see if I could just get these all the way I expected. Okay. Compiled and one warning. Oh, all right. PAIP :fail. Now this would work with no things. Okay. So let's do that one more time. Because since we're kind of exporting this and using this, what I had to do is kind of essentially update the use Eliza rules function to actually use it all. Like, oh, we're going to be exporting this everywhere. Not a good idea, but it will it will serve our purposes for the time being until I actually create proper exported symbols. Hmm. Let's see. Eliza, hello. Hmm. Let us see what's being passed into this just for the time being. We're going to do some printf debugging here. Um, Okay. Okay, let's see what happens if I do hello here. It is not recognizing that I actually updated the function, even though I did. Okay, hold on. We're going to have to do this again. Then reload this. I'm going to restart and reload all of this again. See if this kind of works. PAIP exercises. Okay. Set package to PAIP exercises. Then AFP Eliza. And if I do hello, what happens here? Boom. Okay. So we didn't actually go and recognize it again. Let's do that. Or this. Okay. Let's see. Interesting. If I call, let's see here. Not of type sequence. Okay. I'm going to try something a little different now, since it looks like this is in the wrong thing. So let me go and quickly do this. Do set, I have to set the package to PAIP. And let's just call AFP from here, because in this namespace it should be there, sorry, or this package, it should be there. Right, so I'm going to have to first call IP exercises, AFP Eliza. Okay. There we go. So this is kind of what I was expecting would be the final resort. I didn't want to get to this point just mainly because of the fact that for various reasons, this first it looks ugly, number one. Number two, my understanding of symbols is a little bit off. So let me explain a little bit for some folks who are just joining in or still not familiar entirely what symbols are in Common Lisp. So coming from programming languages, when you are parsing something, all right, that input that gets parsed becomes in Common Lisp what's called a symbol object, okay, which contains a piece of text that essentially could point to either a variable and or a function. The reason why I say and or is because Common Lisp is what's called a Lisp 2, which means that there are different packages, if you will, or namespaces for these kinds of symbols, specifically for variables and for functions. Okay, so if you read, say, Practical Common Lisp, it actually introduces this a little bit, but doesn't go into too much detail about this. But because of this, we have this notion in packages of exported symbols, which you could think of like if you are doing a C++ project, they are your um, uh, symbols that are wrapped around DLL import, I believe it's called. And or if you're in Linux, I'm forgetting the exact export macro. It's like a symbol specific that you need to go and say, hey, this symbol is going to be part of my public API. Go ahead and make sure that when you create the DLL, the symbol is exported. Okay, so that's what an exported symbol is. In the case of packages that are, sorry, symbols that are not exported by a package in Common Lisp, you could still access them and invoke them by using the colon colon operator. And you've heard many times on this stream that colon colon should be used very, very carefully because there's a reason why the package author or the library author, as we can see here, why they originally did not export that as part of an export public API. But in order for us to like write these kinds of extensions and do these kinds of problems, some of those need to be available. So two ways of actually going around and doing this is one is to make sure that you are in that package's namespace where the symbols are reside and be able to then exercise it. Otherwise, you need to do something slightly different. So obviously, in our case, since we are using his program and I was trying to not to modify it, I just tried to simply change it so that I can access it directly from my package, but that didn't clearly work. And the only option was is to exercise and execute our functions that we've defined in our package unimported as part of PAIP, so we could switch between them in the Lisp REPL. Um, um, are there any questions about this? So we can easily tell that we could convert this back to a um, a natural language response by just doing the same thing that we got here when we write out the response from the write function that was defined in our auxiliary function library that was provided by the PAIP project. The one thing we could change is naturally instead of calling write, we could write out to string um, the response that was provided to us, and then it should do functionally the same thing. Now, let me do one thing here. Um, ba, 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 ba. Let's go to, I think I have this open at some point here. We go, this function, and let's go to the write function. Where is it? Hold on. Is to, okay, let's see if I could do by here. Okay, it looks like this version doesn't have it, but the regular Eliza does. Um, let's go ahead and add that. Okay. Okay. Um, we're gonna have to like take this the issues and then be able to print it out. Give it a second. Let me go and see what we could do. Um, actually, let's do this. Let's instead of AFP that, let's do, and let's see what happens when we run this like that and see what hello does. Hello isn't actually being written to anything. Oh, right, because let me just do that instead of doing write, which is doing the formatting for us. Um, so what we need to do is do that. Come here and let's change this to a format T, and let's do we're going to use essentially the iterators that are available to us as part of the format library. If you recall, the format library actually has this ability to actually go through and spit out um, everything from a list. So let's try and see if we could get a format string. If I remember, if I just do this in space, then just provide a tilde, and this should actually do what we expect it to do. Okay. Yep, there you go. And that's it. And now we've completely finished the ability to um, uh, the natural front end to this. Although here in this case, we have a couple of small bugs that we have to kind of deal with, especially when it comes to punctuation. So that's chapter 5 in a nutshell. Um, Again, this was just kind of a quick overview of how to quickly get a natural language interface. I did not complete all of the punctuation stuff that would have been talked about, but you can see that just by simply writing a small bit of code and adjusting how we read in the inputs, we can actually go and leverage all the existing code as is because we're effectively transforming the data from one representation to S expressions. But this also brings up another well, another lesson, so to speak. And this is something that was brought up in chapter 6, which is talking about building software tools. And specifically, it's that if you noticed, Eliza and GPS, and even our natural extension to Eliza, all of them are doing kind of the same thing. They're taking in some input, they're reading it, they're transforming it, and they're evaluating what is provided through some sort of set of rules. All right, and then they're printing out the response and looping through it. Okay, um, this is kind of repetitive, and this is the kind of thing that if you see in a lot of languages, what you would do is you would refactor it into a function formatted in such a way that you could pass in what could be passed in, what is configurable, what is different from these things as parameters into the function, and it will actually go in and construct it for you. Okay. In the case of our read eval print loop, we actually have that a lot um, available for you. Now, if most of you recall, Common Lisp was one of the first, if not the first, if I'm not mistaken from history, um, to create the REPL. Okay, and it's based on the actual Lisp functions that are available to you. Okay, um, you can write a very simple, um, and this is very trivial, but it illustrates what the interpreter is all about. It's literally for function calls. Okay. Um, I'm sure many of you have seen when people talk about Lisp, this loop. Okay. Um, e print. Sorry. Print. Print. Eval. Read. Sort of code. Okay. And this just simple form actually effectively is a Lisp interpreter in Lisp. Okay. Now that is saying a lot in so little. So you might be wondering, for those of you coming in and are new to Lisp, what exactly this syntax means. What is this? Like, let's dissect this a little bit, right? And it comes from programming languages, all right? So normally when we write programming languages, let's say if we're doing Python and we're writing a Python interpreter from scratch, okay, you have to build what's called a syntactic parser that will actually lexically take in your input as a string typically, and it will read each character by character and create these individual symbols that we've talked about, except they're Python symbols in this case. And those symbols might have semantic meaning based on the grammatical structure of the program. So in the case that if you see a DEF in Python, you know that that is defining a function. Okay, so that syntactic meaning when it's interpreting that piece of code, it'll know that it's creating a new function definition. So it will automatically take the rest of the pieces of code and pass it into a function that says generate function definition. All right. In Lisp, a lot of that is provided for you for free through the reader, through that read function that you see there in line 36. Okay. So what you get if you're using proper Lisp syntax from the reader, and we've talked about this multiple times on this stream, so I am repeating myself on this, but it's always good to kind of do a review of this. You are getting S expressions for free and the reading of S expressions for free from the Lisp reader. All right, you'll get Lisp objects reading for free from the Lisp reader. So as long as you maintain your stuff in S expressions, or as you saw what we did before, be able to convert something from another format, in this case is natural language, to something that looks like an S expression, which we did when we, converted our natural language input into a string of inputs and then converted those into Lisp symbols using read from string. You also are able to take advantage of the parser for you for free. Eval is also the same thing. If there are special symbols that you're leveraging that can map to actual Lisp code, all right, and you can convert your code into S expressions in a form that could leverage those same Lisp functions, you also can get half of your evaluation for free. Okay. Um, the advantage of this kind of ability to write these things is that you can leverage as much as your tool as you can. And that's kind of the key point when you're doing some of these refactors, right? And one of the nice things about this structure is that this is so common when you're building stuff in Common Lisp that you could write a simple function for you at your disposal, like without too much effort. Okay. Um, One of the things that was brought up in um, chapter 6 on this was the so-called interactive interpreter, where you can actually call or create a prompt that essentially allows you to you could pass in and it could just generate this. So this is something that we've seen in the book, and I'll just show it here without getting into too much details about it. We'll do a quick code review. You could have something called um, interactive interpreter, as the book calls it, not interactive, interactive interpreter, taking in, say, a prompt, okay, and what we will call a transformer function. But the transformer function is nothing more than a function that you could implement your parsing and ability stuff to it. And then you just leverage loop the same thing that you saw before. You could use the loop code here. You could print out your prompt, okay, and then you could end up leveraging what's it a fun call to simply print out your transformer output on the input that's being passed in from standard in. Okay, that's about it. I mean, this is essentially everything that you could do, and you can use this syntax to actually implement many types of interpreters. Okay, it's the same thing, and as long as you're able to convert that into a read function, it'll be fine. Before I continue, I know many of you might be wondering, well, you're going a little ahead. You didn't actually go and talk about named read tables. Um, the reason why I didn't need to is because the remaining thing here, and we've talked about name read tables on this program before, on this in our study group. So I don't and designing reader macros, okay, from if you recall our cipher example, that it doesn't necessarily require too much effort to actually go and see um, that with this get next line, you just need to go in and update the appropriate reader macro characters in your read table to define your read table for Eliza syntax, and you should be good to go. There isn't anything special that you need to even take care of. Okay. Um, so I'm gonna leave that kind of as an exercise, just because the natural language piece there is kind of the bigger thing that we wanted, which we were able to kind of show off without having to actually modify read tables again. But adding the read table extension is really not a far stretch from where we are, because you just need to simply use the macro car keyword to specify which characters that you need to really handle specially, and then the rest will go through the standard reader, and you can actually go in and be able to um, uh, do natural language parsing into S expressions so that Eliza can actually read in those inputs and be able to execute the code. Okay. All right. So let us now get back to, hold on, what's this? Oh, right. This is the difference between doing copy read tables and doing name read tables. Right. Okay. So let's go back to this here. Okay. So the interactive interpreter things is particularly interesting in chapter 6, but it's really not as interesting as generalizing, like, say, the pattern match stuff that they've created. Um, we've actually went ahead and we've talked about the pattern match function, but we didn't actually go and look at how it is implemented and what it kind of encourages. So if we go back to our auxiliary functions that was in here, and we go to PAIP match, which is here, you can see that this pattern matching is slightly different than pattern matchers that are defined in um, newer languages. If you're used to the match with syntax coming from the ML family. Um, Now I'm going to say up front, those are kind of they're more or less syntactic variations. Okay, so like you could technically write a reader that creates a match, all right, and make that match syntax call out to pat match in the same way that match width does. But this is essentially a very simple pattern matcher that allows you to just simply define a predicate that you can put in to a condition branch, and it'll go ahead and dispatch based on the particular um, predicate's execution, right? Whether or not that particular predicate returns true or false. Um, this is essentially how all pattern matchers fundamentally work underneath. Okay, um, and you can extend this to actually deal with constants and other types of variables and things. And chapter 6 kind of goes through on how to kind of cover some of that. I'm not going to really leverage a lot of what was already kind of provided in terms of explanations. One thing I found interesting when I read this chapter is his definition of what we would consider we call what's it, data driven programming. So I wanted to kind of discuss that a little bit, just to make sure I understood it correctly, and other folks can chime in the comments and tell me whether or not that's not what he meant or whatnot. um so what is this uh why is this called data-driven programming, or why is this considered to be a form of data-driven programming? Well, as data-driven programming's name indicates, you are looking at particular patterns, and based on particular patterns inside of a data stream, you are taking certain actions on top of it. Okay, and a lot of formats and parsers that are out there end up doing the same sort of kind of style of recognize pattern, execute action. All right, and it's actually very similar to what we consider to be like what robots end up doing, like in situational awareness systems. It's the same sort of idea. They take in some inputs. Those inputs recognize are particular data sources of information. That information is then passed into what the robot would be considered to be a pattern recognition system. That pattern recognition system will incorporate and create a set of actions that it should execute, and it will go ahead and execute them. So this is very much in the guise of what we would normally do anyway anywhere. And so my particular uh, interesting discovery is that if you generalize, or at least pers- not so much generalize. If you actually define data-driven programming to be essentially pattern recognition that results in the creation of actions, then this table-driven style of programming becomes one type of data-driven programming. Data-driven programming versus, say, what a lot of folks would probably end up leveraging is uh, the ability to synthesize data in a particular format as a way of doing data-driven programming to inform a particular system. So your fuzzers are an example of this. Uh, the generalized patterns that we've created for Eliza specifically ended up using some techniques that allowed us to be able to write these generalized rules specific, but those are specific to Common Lisp. Those aren't actually necessarily um, something that you would end up having to do in other languages. All right, and what I'm talking about is the clean star things that we saw when we were looking at the Eliza rules. All right, um, so if you look at where is it, Eliza rules there. So this kind of clean star with the special variable stuff. That's actually using binding, so we can do sublists and stuff inside Common Lisp. But you could imagine this ability to be able to generalize this to be creating things like a matcher dispatch sort of like style of function. And this is what he kind of incorporated in his examples for generalizing the bindings piece in logic into using the segment pattern logic that he created here in his auxiliary library. So go back to this. Um, do segment. Uh, oh, right. Not in the auxiliary, it's in the complete implementation. Segment. Okay. Yeah, this notion of segment pattern that we talked about before, which uses segment match and all this that takes in those segment variables that we created and be able to execute particular types of pattern matchers on top of them. The dispatcher function stuff, I'm not going to really cover too much on just because that's kind of the generalization of what we've already talked about. Um, and but yeah, chapter 6 really was this notion of, well, you've kind of looked at two tools that essentially are doing some sort of pattern recognition and a lookup. Is there a ability to be able to generalize these into more specific tools that you could then leverage? And honestly, I think the most advantageous one of all of them was his shouting out to the general interactive interpreter pattern. And I want to also mention that that interactive interpreter pattern is the same pattern that you would end up actually seeing if you've read design patterns. The design pattern approach is nothing more than the the C++ object orientation version, so to speak, of the interactive interpreter pattern that's presented here. The only difference is they're more explicit on the design of the parser. Whereas here and in Common Lisp, if you end up wanting to write a parser, you would almost always end up creating some sort of read table set of patterns to allow the parser be an extension of the Common Lisp code. You'll convert that into an S expression that can match its syntax into a set of forms that can directly map themselves to Common Lisp functions, and only those cases where you really need to write some code would you end up writing the dispatch for that for the evaluation. So you'll be like it'll be a small extension piece of code, but the majority of it is literally bridging the syntax of your new language into Common Lisp, and it'll be a pretty straightforward exercise from there. That's all I have for today. Um, I was hoping there would be more discussion, but I apologize for the little divulgence. But it's all in good fun. Are there any final questions? All right. Um, in that case, join us next week when we are going to be discussing um, chapter 7, which is going to be we're going to be talking about um, another type of tool that you could end up defining in um, in Common Lisp, and that's for creating searches, like generalized search tools. And we'll also discuss chapter 7, which is talking about our next AI program, and that is solving algebra word problems, which is going to be pretty interesting. I'm actually excited about this one. So, end of it'll be middle of chapter 6, end of beginning of chapter 7. We're going to probably also we're also, as usual, going to do some interesting common list problems along the way. Again, those of you who like our content, please subscribe or hit the bell icon, and we'll hear about new talks that we bring up. AFP is looking for speakers to give talks both online and in person. Reach out to me on Slack and or Discord and propose your topics. And with that, I will hope to see you guys next week. Thank you for joining. Bye.